This is Katie Bowman's AP problem number 3. So we're going to start off by reading our first question, which is methane gas reacts with chlorine gas to form dichloromethane and hydrogen chloride as represented by the equation above, which is given to us right here. So A asks us, a 25-gram sample of methane gas is placed in a reaction vessel containing 2.58 moles of Cl2, and then part 1 of that asks us, identify the limiting reactant when the methane and chlorine gases are combined. Justify your answer with a calculation. So we're going to look right here for part 1. We're going to use the 25 grams of chlorine that, or 25 grams of methane that it gives us. We're going to convert that into moles. We'll do a mole to mole ratio and then convert the CH2Cl2 into grams. That's going to give us 132 grams of CH2Cl2. And now we're going to do the same thing for the moles of Cl2. So it gives us 2.58 moles. We're going to do a mole to mole ratio. We're using the equation above to get those mole ratios. And then we're going to convert CH2Cl2 into grams. That's going to give us 109.52 grams of CH2Cl2. So since this number here is smaller, we know that this here is our limiting reactant. Alright, so the second part of A is calculate the total number of moles of CH2Cl2 in the container after the limiting reactant has been totally consumed. So, let's pick this up, oh, there we go. Okay, so part 2, we use the limiting reactant's answer here. We're going to use 109.52 grams of CH2Cl2. We're going to convert that into moles. It's going to give us 1.29 moles of CH2Cl2, and that's our answer. So now let's move on to the second question, which also gives us a balanced equation. And the second question reads, iron reacts with oxygen to produce iron 3 oxide as represented by the equation above. A 75-gram sample of iron is mixed with 11.5 liters of oxygen at 2.66 atm and 298 Kelvin. Part A asks us to calculate the number of moles for each of the following before the reaction begins. So that's iron and oxygen. So we're going to look at that part right here. So we're going to use the 75 grams of iron that it gives us, and we're going to convert it into moles. It's going to give us 1.34 moles of iron. But for part 2, when we're looking for the moles of oxygen, we're going to use the ideal gas law, PV equals nRT, to find it. And in the question, it gives us all of the answers that we need except moles. So that's going to be our X, our unknown. So we're going to plug in 2.66 atm for our pressure, 11.5 liters for our volume, X is our moles or N, and then 0.0821 is our constant R, and 298 Kelvin is our temperature. And when we plug that into our calculator, we get 1.25 moles of O2. So now let's move on to part B, which asks us to identify the limiting reactant when the mixture is heated to produce Fe2O3. Support your answer with calculations. Okay, so when we look at part B, we use the moles that we just calculated up here for our starting, so it's going to be 1.25 moles of O2. We are going to do a mole to mole ratio using the equation that it gave us in the original question. So we're going to use 1.25 moles of O2, mole to mole ratio, it's going to give us 0.83 moles of Fe2O3. We're going to do the same thing for iron. We use 1.34 moles of iron, mole to mole ratio, it's going to give us 0.67 moles of Fe2O3. So our limiting reactant, because this one is smaller, turns out to be this one, so it's our limiting reactant. Okay, and then part C, calculate the number of moles of Fe2O3 produced when the reaction proceeds to completion. And so, since for part B, I had converted them already into moles, we're just going to use our limiting reactant's answer as the number of moles that is produced, which is 0.67 moles of Fe2O3. that's it. Thanks for watching.